Now we're going to take a look at how to deal with branched alkanes in terms of IUPAC naming. And so for this video, we will be trying to figure out the name of the structure shown here. There's a process that you have to go through to be able to name something like this. So we're going to see that there's a series of steps that you need to follow. And the first of those steps is going to be finding the longest continuous carbon chain, because that's going to tell us what the root name or parent name of this compound should be. So you can see that the numbering scheme that's written in yellow is the longest continuous carbon chain, and that would be 9 carbons in a row. So the root name of this particular structure is going to be a nonane. We now need to identify what we consider substituents on this parent chain. So I can see that if I use the numbering scheme in yellow, that I have a group sort of dangling off of carbon 2, carbon 3, and carbon 5, and those are going to be our substituents. I've chosen to number the carbon chain in this fashion as opposed to starting down here and numbering this way, because when you number, you want to put the first substituent on the lowest number possible. So having the first substituent on carbon 2 is preferable to having the first substituent on carbon 5. So our parent chain is circled in yellow, and what we are calling substituents are circled in purple. And now we need to give a name to each of these substituents. So the 1 carbon substituent is just going to be methyl. We have another methyl here also. And then here the 2 carbon substituent is going to get the name ethyl. If you haven't picked up on this already, I was using the terminology methyl and ethyl on the previous slide. Hopefully you notice a pattern that, just like for naming alkanes, if it's a 1 carbon piece, we use the prefix meth, 2 carbon piece eth, and so on. But instead of putting an ane ending like you would for an alkane, when it's a substituent, you put a yl ending on the end. So a 3 carbon piece would be a propyl group. Specifically, this one that's shown here is an N-propyl group, and that's to indicate that the group is being connected to the rest of the chain through the terminal or end carbon there. If you have 3 carbons in a row, but they are not connected through the end carbon, but rather through the middle carbon, this would be what we call an isopropyl group. Similarly, with a butyl group, when you have the 4 carbons in a row and it's connecting through the end, this is called an N-butyl group. If you move over one and you go through one of the carbons in the middle on this straight chain butyl group, this is called a sec-butyl group. It gets a little bit more complicated when you have 4 carbons, because they can be arranged in a way besides just in a straight chain. So say there's an arrangement like this one, and we are connecting through the end. This would be called an isobutyl group. Whereas if we were connecting through the middle carbon, this would be called a tert-butyl or a T-butyl group. You do need to know up through 10 carbons in a row, pentyl, hexyl, and so on. Now, I do not hold you accountable for knowing all the different isomers and ways that these can be arranged when we get to 5 carbons or more, but you do need to know the butyl isomers, so you need to know those 4 different ways that 4 carbons can be arranged, and then just know the straight chains once we get to 5. Now let's go back to the compound that we're trying to name. Recall that we had 2 methyl groups, one at the 2 carbon and one at the 3 carbon. So we're going to actually put these 2 together and call this an overall dimethyl group. If there would have been 3 methyl groups, we would have put a tri prefix in front of it. 4 groups, a tetra prefix in front of it, so trimethyl or tetramethyl, and so on. Then we are going to list these substituents in alphabetical order. There are a few rules that you need to consider when you're alphabetizing. The first of those is that you do not count prefixes that are hyphenated. So for example, sec-butyl is a hyphenated substituent, and so we do not actually pay attention to the SEC part. We alphabetize it based on the B. However, something like isopropyl is different because it is not hyphenated, so we actually alphabetize it based on the I. We also do not count prefixes like di, tri, or tetra. So tripropyl would just be alphabetized based on the P. Going back to our structure, we have an ethyl group and then the dimethyl to account for the two groups. And so we're going to alphabetize this based on the M in methyl and the E in ethyl. And of course, E comes before M. Then we will insert a number that refers back to the carbon on which each of these substituents are located. So our ethyl group is on carbon 5, and our two methyl groups are at the 2 and 3 position. So this is a 2,3 dimethyl. Then we put it all together and list the substituents alphabetically with the numbers in the front as seen down here on the left. And then we end with the name of the parent chain. So overall we have a 5-ethyl 2,3-dimethyl nonane. And now the best thing that you can do for yourself is practice, practice, practice. There should be a lot of naming problems at the end of chapter 4.